Welcome. Today, we're diving into the crucial role of humidity control and contamination prevention in sterile manufacturing. I'm Dr. S.K. Singh, and together, we'll explore how managing these factors keeps products safe and effective. Let's get started. Let's start by understanding relative humidity, or RH. It's the amount of water vapor in the air compared to the maximum it can hold at a certain temperature. In sterile manufacturing, keeping RH within specific ranges is crucial. Too high or too low, and we risk contamination, static buildup, or even equipment failures. This table shows typical RH recommendations for different areas, from aseptic filling to lyophilization support. Each range is carefully chosen to protect product quality and ensure smooth operations. When it comes to humidity control, regulators have clear expectations. The EU's GMP Annex 1 calls for defined and controlled environmental conditions, with continuous monitoring of key factors, all integrated into the broader contamination control strategy. The FDA emphasizes that environmental conditions can't negatively impact product quality. Meanwhile, WHO and PIC SGMP require qualified HVAC systems, strict control of environmental parameters, and ongoing monitoring programs. At the core, all these regulations agree humidity limits must be backed by solid scientific risk assessments tied to the product and process. Let's explore how humidity levels affect contamination risks. When humidity is high, microbes can multiply faster, condensation can form, and surfaces become more prone to contamination and biofilm buildup. On the flip side, low humidity brings its own challenges. Static electricity increases, particles shed more, and electrostatic forces attract contaminants. These factors impact critical areas like sterility assurance, environmental monitoring, product quality, and staying compliant with regulations. Balancing humidity is key to managing contamination effectively. Let's talk about what happens when relative humidity climbs above 60%. High humidity creates a perfect environment for microbes to thrive. Bacteria, yeasts, and molds all find it easier to survive and multiply. Fungal growth becomes a real concern, with common culprits like Aspergillus, Penicillium, and Cladosporium species taking hold. For example, one cleanroom saw humidity jump from 45 to 72% after an HVAC failure. Microbial counts rose sharply, triggering a full investigation and assessment of product safety. This shows just how critical humidity control really is. Let's talk about condensation and how it leads to moisture-related contamination. Condensation happens when warm, humid air meets cooler surfaces. This causes water to collect, creating droplets. Those droplets aren't harmless. They encourage microbes to grow, contaminate surfaces, and even corrode equipment. For example, in a room at 21 degrees Celsius with 75% humidity, a pipe at 14 degrees will have visible condensate on its surface. This is a serious concern, as EU GMP Annex 1 highlights condensate as a major contamination risk that must be prevented. When relative humidity drops below 30%, we start to see some serious risks. Low humidity boosts surface resistance, which means static electricity builds up more easily. That static charge can then discharge suddenly, causing all sorts of trouble. The consequences: more airborne particles, higher chances of product contamination, and even equipment malfunctions. For example, at just 25% humidity, particle counts jumped from 3,500 to 9,000 per cubic meter, nearly tripling the contamination risk in critical areas. This is a clear warning sign for maintaining proper humidity levels. Now let's look at how moisture affects sterile product quality, especially those sensitive to water. Think sterile powders, lyophilized injectables, biologics, and vaccines, all vulnerable to moisture. When exposed, they can undergo hydrolysis, lose potency, fail stability tests, or even suffer packaging damage. For example, a sterile antibiotic powder exposed to high humidity during filling showed higher moisture levels, lower assay results, and ultimately failed stability studies. Moisture control is critical to keep these products safe and effective. Let's talk about HVAC systems and how they manage humidity. On one side, we have dehumidification, using cooling coils or desiccant wheels to pull moisture from the air. On the other, humidification, adding moisture back in with clean steam humidifiers or controlled injection. But it's not just about humidity. These systems also handle HEPA filtration, airflow control, and maintaining pressure cascades. For example, a sterile filling facility relies on automated HVAC to keep relative humidity steady at 45 plus or -5% during production. Let's talk about humidity and environmental monitoring, two critical parts of keeping conditions safe and stable. We use continuous monitoring with relative humidity sensors, building management systems, and SCADA platforms to keep a constant eye on things. This integrates seamlessly with the environmental monitoring program, tracking key parameters like humidity, temperature, pressure differences, particle counts, and even microbial levels. For example, if humidity hits 50%, an alert sounds. At 55%, action is triggered immediately. These automated alarms help us catch problems early, before contamination becomes a real threat. Let's talk about a risk-based contamination prevention strategy, one that combines engineering, administrative controls, and risk management. On the engineering side, we rely on qualified HVAC systems, precise sensor calibration, and continuous monitoring to keep conditions stable. Administrative controls include clear standard operating procedures, thorough operator training, and regular preventive maintenance. Risk management ties it all together with humidity assessments, trend analysis, and corrective actions. For example, predictive HVAC maintenance cut humidity excursions by 85% each year, a powerful result. Let's break down the key lessons on humidity control. When humidity drops below 30%, static builds up, and particulate contamination rises, both big risks. Between 40 and 60%, we hit the sweet spot. Contamination is controlled, products stay protected, and regulations are met. But above 60%, microbes thrive, condensation forms, and products degrade. Meeting regulatory expectations means setting science-backed limits, using qualified HVAC systems, monitoring continuously, and keeping data integrity front and center. It's a cycle of review, trending, and investigation to stay on track. Humidity control plays a crucial role in keeping sterile manufacturing environments clean and safe. By carefully maintaining humidity within scientifically set limits, we can reduce the risk of microbial growth and prevent particles from contaminating products. It also helps avoid condensation issues and protects moisture-sensitive materials. When combined with strong HVAC systems and thorough monitoring, effective humidity management becomes a key part of any contamination control strategy. This approach not only supports product quality, but also ensures we meet strict regulatory standards, keeping sterile manufacturing reliable and secure. That brings us to the end. If you need any more support or have questions, please don't hesitate to reach out. Thank you for your time and attention. It's been a pleasure sharing this with you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.